Okay, so today we're talking about the zero product theorem. So it's something that we've done in math since Algebra 1, but it might not be a concept that we really think about that often. That is this: if we have two or more things that are being multiplied together and their product is zero, so let's say like A times B is equal to 0, then either A is equal to 0, B is equal to 0, or they both are equal to 0. That has to be true if their product is 0. So we're going to use that concept to solve the following trig equations. So we're going to start with number 1 here. We've got this: the cotangent of x is equal to 2 times the cosine of x. Now, there are a couple of things that we've got to do in order to solve this. The first thing is this: cotangent and cosine. We want things in terms of generally cosine or sine. So I'm going to work at getting that cotangent into terms that we can see better. And that means that I'm going to turn cotangent into the cosine of x over the sine of x. So remember, cotan is cosine over sine, and that is equal to 2 times the cosine of x. Okay, next, we got to get one side equal to 0, just like any other algebra equation, and then we'll see what happens. So I'm going to multiply both sides by the sine of x in order to get rid of the fraction. I don't like fractions. And so then what happens is we get the cosine of x is equal to 2 times the cosine of x times the sine of x. And here is where we're going to run into a problem, and I'm going to see a lot of people do this. Okay. Looking at it like this, a lot of people are going to say, why don't we just divide by the cosine of x, and then they go away here and we get 1 on the other side. Okay, here's the problem. When we're solving trig equations, we cannot divide to cancel. That is super important. If you divide to cancel, you end up losing half of the solutions. And then in a problem like this, which is what your test is going to look like, that's going to be a lot of points. So we don't want to do it that way. Here's how we're going to do it. Oh, I got to go back all the way back here. I am going to move everything to one side. I'm going to get 0 on the left, and I'm going to subtract the cosine to the right. So that is going to become this: 2 times the cosine of x times the sine of x minus the cosine of x. And then what happens is I have two terms that have a cosine, two terms that have a similar or a like term. So I'm going to factor a cosine out of both of the terms on the right. And so that's going to give us the cosine of x times 2 times the sine of x minus 1. All right, and so what happens now is we've got two factors. We've got the cosine of x and then 2 sine x minus 1. And using that zero product theorem, we can say the following: either the cosine of x has to equal 0, or 2 sine of x minus 1 has to equal 0. And from there, we can find the principal values, and we can start setting up those general solution equations, and then looking into the solutions between 0 and 2 pi. Okay, so the cosine of x, that is going to yield a principal value, right? We're looking for the angle whose cosine is 0. The angle whose cosine is 0 is pi over 2. That's our principal value there. And then here, we're looking for where sine of x is 1/2. We're looking for the angle whose sine value is 1/2. That is going to yield a principal value of pi over 6. That's the angle whose sine is 1/2. All right, so when we go to write the general solution equations, we're going to get solutions for both principal values. So let's start with that pi over 2. Now, that comes from cosine. We took the inverse cosine of 0 in order to get the principal value, pi over 2. So we have two general solution equations that come from cosine. The first is the principal value plus 2 pi n. And then the second equation is the negative principal value plus 2 pi n. Those come from cosine, all right? And that comes from that principal value, pi over 2. Okay, let's see if I can color code this then. Next, we've got that principal value, pi over 6. Now, that came from sine. That came from taking the inverse sine of 1/2. So in order to represent those equations, we're going to use the equations for sine. So that is the principal value plus pi over 2, or 2 pi n, excuse me. And then the fourth equation, remember for sine, it's pi minus the principal value. So this is going to be pi minus pi over 6, so that's going to give us 5 pi over 6 plus 2 pi n. So those together are the final general solution equations for this equation. So that's part A. And then part B is to find those particular solutions between 0 and 2 pi. So that comes from either making a table and then plugging them in or doing that. Now we're going to go one step further today, and we're going to be looking at the solutions on the graph. So let's find the solutions between 0 and 2 pi, and then we'll work on graphing them. So when I make a table of values, and I'm keeping track of theta 1, theta 2, theta 3, theta 4, what ends up happening is we get the solutions that look like this, all right? So we would get pi over 6, we get 5 pi over 6, we get pi over 2, and we get 3 pi over 2. Those are all of the solutions when we make the table between 0 and 2 pi. Now, we want to put these on the graph. We need to find a way to label these points on the graph. Now, we're going to be marking then the ordered pairs. Remember, we're solving for where the cotangent of x is equal to 2 times the cosine of x. So we're looking for the points where these two functions intersect on the graph. So they're going to intersect up here, right here, and then one more between 0 and 2 pi is that point there, all right? So this is 0, this is 2 pi over here. Now, each one of these solutions we found represents the x value of that ordered pair. I'm going to call this A, I'll call this B, C, D. Okay, and this is why I've been stressing put them in order from least to greatest. So the way I have them written right now is not in order from least to greatest. So I'm going to reorganize those points. Okay, so pi over 6 is going to be that first one. And I'm going to leave it like this, and I'll tell you in a minute. All right, next we've got pi over 2. And then we have 5 pi over 6. And then lastly, we've got 3 pi over 2. Okay, those are the 4 solutions. Now, because they're in order, I know they correspond with the points going left to right, right? How I've marked them, A, B, C, D. The last thing we're going to do, and this is what you guys are going to do on your test as well, is we're going to find those y values that correspond. So we're looking for each of those y values that go with that ordered pair. Now, the way that we're going to do that is we're going to go back to the original equation. So go back to the top, and you're going to pick a side. Left or right does not matter to me. Let's just choose 2 cosine x. What I'm going to do is I'm going to plug each of those numbers in to 2 cosine x to get the y value. Okay, so that's what we're going to do here. So pi over 6, when I plug that into 2 cosine x, that becomes 2 times the cosine of pi over 6. All right. That is going to become 2 times the square root of 3 over 2, which is just going to be the square root of 3. All right, I'm going to do that again with pi over 2. That becomes 2 times the cosine of pi over 2. Well, the cosine of pi over 2 is 0. 2 times 0 is just 0. Moving on, this becomes 2 times the cosine of 5 pi over 6. Well, the cosine of 5 pi over 6 is going to be negative root 3 over 2. So times 2, which is just going to leave us with negative root 3. And then lastly, 2 times the cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0 again, so that is going to be 0. And we see that in point D here, these two things intersect when the y value is 0, right? That would be the x-axis right there. Okay, so let's do it again for the next problem, but that is essentially what we're looking for. Your test is going to look like problems like this. Given a graph, you're going to have to also identify the ordered pairs where the two functions intersect.